वेलकम टू द सपना झोम स्कूलिंग चॅनल. नमस्कार मित्रांनो, मी रवींद्र. आज आपण 10th स्टँडर्ड सायन्स अँड टेक्नॉलॉजीचा 4th चॅप्टर इफेक्ट्स ऑफ इलेक्ट्रिक करंटची एक्सरसाइज चेक करणार आहोत. ओके, तर बघा, फर्स्ट क्वेश्चन काय, टेल द ऑड वन आउट, गिव्ह प्रॉपर एक्सप्लेनेशन. फ्यूज वायर, बड कंडक्टर, rubber gloves and generator. Okay, the answer is generator because it converts mechanical energy into electric energy. The remaining three do not. Voltmeter, ammeter, galvanometer, thermometer. Answer is thermometer. It measures temperature. The remaining three are measures electrical quantities. Loudspeaker, microphone, electric motor, magnet. The magnet, it exerts a force on a magnetic material. The remaining three converts one form of energy into another. Question 2. Explain the construction and working of the following. Draw a neat diagram and label it. Electric motor. The answer is figure shows the construction of an electric motor. Here a rectangular loop ABCD of a copper wire with resistive coating is placed between the north pole and south pole or a strong magnet such as a horseshoe magnet, such that the branches AB and CD are perpendicular to the direction of the magnetic field. The ends of the loop are connected to the two halves of X and Y. Of split rings, X and Y have resistive coating on their inner surface and are tightly fitted on the axle. The outer conducting surfaces of X and Y are in contact with two stationary carbon brushes E and F respectively. Working. When the circuit is completed with the plug key or switch, the current flows in the direction E, A, B, C, D, F, as the magnetic field as is directed from the north pole to the south pole. The force on AB is downward and that on CD is upward by Flamingo's left-hand rule. Hence, AB moves downward and CD upward. These forces are equal in magnitude and opposite in direction. Therefore, as observed from the side AD, the loop ABCD and the axle start rotating in the anti-clockwise direction. Okay, draw this figure neatly. After half a rotation, X and Y come in contact with brushes F and E respectively, and the current flows in the direction EDCBAF. Hence, the force on CD is downward and that's on AB is upward. Therefore, the loop and the axle continue rotate in the anti-clockwise direction. After every half rotation, the current in the loop is reversed and the loop and the axle continue to rotate in anti-clockwise direction. When the current is switched off, the loop stops rotating after some time. B. Electric generator, AC. Okay, so figure shows the construction of an AC electric generator. Here a coil ABCD of a copper wire is kept between the pole piece N and S of a strong magnet. The ends of the coil are connected to the conducting rings R1 and R2 via carbon brushes B1 and B2. The rings are fixed to the axle and there is a resistive coating in between the rings and the axle. The stationary brushes are connected to galvanometer used to show the direction of the current in the circuit. Working. When the axle is rotated with a mechanic with a machine from outside, the coil ABCD starts rotating. Suppose the coil rotates in clockwise direction as observed from the side AD. Then as the branches AB move upward, the branch CD moves downward by Flamingo's right-hand rule. The induced current flows in the direction A to B to C to D, and in the external circuit it flows from B to B through the galvanometer. The induced current is proportional to the number of turns of the copper wire in the coil. Okay, see the diagram. After half a rotation, AB and CD interchange their places, hence the induced current flows in the direction D to C to B to A, as AB is always in the contact with the B1 and CD is in contact with the B2. The current in the external circuit flows from B1 to B2 through the galvanometer. Thus, the direction of the current in the external circuit is opposite to that in the previous half rotation. The process goes on repeating and alternating current is generated. Question 3. Electromagnetic induction means charging of an ion, charging of an electric conductor, production of magnetic field due to current flowing through a coil, generation of a current in the coil due to relative motion between the coil and the magnet, motion of the coil around the axle is an electric motor. The answer is generation of current in a coil due to relative motion between the coil and the magnet. The explain the difference. Okay, AC generator and DC generator. Okay, so AC generator and DC generator different. The AC generator, okay, the rings used are not split. In the DC generator, split rings are used. The direction of the current produced reverses after equal intervals of time. The current produced flows in the same direction all the time. Question 5. Which device is used to produce electricity? Describe with the neat diagram. Okay. Electric motor, galvanometer, electric generator and voltmeter. The answer is electric generator. And this is the diagram of electric generator. Okay. Dear students, please draw neatly this diagram. Figure shows the construction of DC generator working. The axle is rotated with a machine from outside when an armature coil of the generator rotates in the magnetic field. Electric potential differences is produced in the coil due to electromagnetic induction. This produces a current as shown by the glowing of the bulb or by a galvanometer. The direction of the current depends on the sense of rotation of the coil. In DC generator, one brush is always in contact with the arm of the coil moving up while the other brush is in contact with the arm of the coil moving down in the magnetic field. Hence, the flow of the current in the circuit is always in the same direction and the current flows so long as the coil continues to rotate in the magnetic field. Question 6. How does the short circuit form? What is its effect? Okay, if a bare live wire phase wire, okay, live wire or phase wire and a bare neutral wire touch each other, okay, come in the direct contact or come very close to each other, the resistance of the circuit becomes very small and hence huge, okay, a very high electric current flows through it. This conduction is called a short circuit or okay, short circuiting. In this case, a large amount of the heat is produced and the temperature of the component involved becomes very high, hence the circuit catches fire. Question 7. Give scientific reason. Tungsten is used to make solenoid type coil in an electric bulb. Okay, the intensity of a light emitted by the filament of a bulb depends on the temperature of the filament. It increases with the temperature. The melting point of the material used to make the filament of a bulb should be very high, okay, so that the filament cannot be heated to a high temperature by passing a current through it, okay, without melting it. This is more important. This enables us to obtain more light, okay. The melting point of the tungsten is very high, hence the tungsten is used to make a solenoid type coil filament in an electric bulb. In the electric equipment producing heat, example iron, electric heater, boiler, toaster, etc., and alloys such as nichrome is used, not pure metal. Okay, the working of heating devices such as a toaster and an electric iron is based on the heating effect of the electric current, that is conversion of electric energy into the heat by passage of the electric current through a metallic conductor. An alloy such as nichrome has high resistivity and it can be heated to a high temperature without oxidation and contrast to pure metals. Therefore, the coils in the heating devices such as a toaster and an electric iron are made up of an alloy such as nichrome rather than pure metal. For electric power station, copper or aluminium wire is used. Answer: the one copper and aluminium are good conductor of electricity. Copper and aluminium have very low resistivity. Hence, when an electric current flows through a wire of copper or aluminium, heat produced is comparatively low. Therefore, electric power transmission, copper or aluminium wire is used. D. In practice, the unit kilowatt is used for the measurement of electric energy rather than the joule. If an electric device is rated 230 volt 5 ampere is operated for 1 hour, electric energy is used is equal to volt is equal to 230 volt into 5 ampere into 3600 seconds. Okay, so that is how much? 41 lakh 40,000 joules. Okay, so counting in the joule becomes difficult. If this energy is expressed in kilowatt, it will be, okay, 41 lakh 40,000 upon 3.6 into 10 raised to 6, okay, kilowatt. So that is 1.15 kilowatt. Okay, more convenient to read. Okay, so 3.6 into 10 raised to 6. Hence, in practice, the unit kilowatt is used for the measurement of electric energy rather than the joule, because it is more convenient to read 1.5 kilowatt instead of counting 41 lakh 40,000 joule. Question 8. Which of the statement given below correctly describes the magnetic field near a long straight current carrying conductor? The magnetic lines of the force are in the plane perpendicular to the conductor in the form of straight line. See, these are the four options you have to answer the correct. The correct answer is the magnetic lines of a force are in concentric circles with the wire as the center in the plane perpendicular to the conductor. Question 9. What is a solenoid? Compare the magnetic field produced by a solenoid with the magnetic field of a bar magnet. Draw a neat figure and name various components. When a copper wire with a resistive coating is wound in a chain of a loop, okay, like a spring, is called a solenoid. Okay, dear friends, draw this diagram neatly. Magnetic lines of a force, magnetic field lines due to a current carrying solenoid. Okay, so here it's battery, plug key, current, north pole and south pole. Okay, the magnetic field lines, magnetic lines of force due to a current carrying solenoid are similar to those of a bar magnet. Okay, one face of the coil acts as the south pole and the other face as the north pole. Now question 10. Name the following diagram and explain the concept behind it. Flamingo's right hand rule. Okay, stretch the thumb, the index finger and the middle finger of the right hand in such a way that they are perpendicular to each other. In this position, the thumb indicates the direction of the motion of the conductor, the index finger the direction of the magnetic field, and the middle finger shows the direction of the induced current. Okay, so this is Fleming's right hand's rule. Fleming's left hand rule. The left hand thumb, index finger and the middle finger are stretched so as to be perpendicular to each other. If the index finger is in the direction of the magnetic field and the middle finger positions in the direction of the current and the direction of the thumb in the in the direction of the force, okay, on the conductor. This is the left hand rule. Okay, now question 11. Identify the figures and explain their use. Okay, here are the two things. Okay, first one is fuse. A fuse protects electrical circuit and appliances by stopping the flow of electric current when it exceeds a specified value. For this, it is connected in series with the appliances or circuit to be protected. A fuse is a piece of wire made of an alloy of low melting point. Example, an alloy of lead and tin. If a current larger than the specified value flows through the fuse, its temperature increases enough to melt it. Hence, the circuit breaks and the appliances is protected from damage. Miniature circuit breaker. Okay, the second image is of miniature circuit breaker. These days, miniature circuit breakers (MCB) switches are used in homes. When the current in the circuit suddenly increases, this switch opens and the current stops. Different types of MCBs are in use for the entire house. However, the usual fuse wire is used. Okay, see, these are some models. Now figure shows the construction of a DC generator. Okay, this is electric DC generator. Here an ammeter is shown instead of the bulb working. The axle is rotated with a machine from outside when the armature coil of a generator rotates in the magnetic field. Electric potential differences is produced in the coil due to electromagnetic induction. This produces a current as shown by the glowing of the bulb or by a galvanometer. The direction of the current depends on the senses of rotation of the coil. In a DC generator, one brush is always in the contact with the arm of the coil moving up, while the other brush is in contact with the arm of the coil moving down in the magnetic field. Hence, the flow of the current in a circuit is always in the same direction and the current flows so long as the coil continues to rotate in the magnetic field. Now question 2. Solve the following examples. Heat energy is being produced in a resistance in a circuit at the rate of 100 watt. The current of 3 ampere is flowing in the circuit. What must be the value of the resistance? Okay, so data here it's given. So P is equal to how much? 100 watt. Okay. I is equal to 3 ampere and R we don't know, so we need to find the R. Okay, the formula here is P is equal to I raised to 2R. Okay, I square R. Okay, so R is equal to what? P, and that I goes other side, so it becomes the denominator. So resistance R is equal to P upon I square. Okay, so 100, P value of the P is 100 and value of the I is 3. So it is 100 watt upon the square of 3 ampere. Okay, it's a square actually. Okay, it's a typing mistake. So 100 upon 9, 3 square is 9. Okay, so when you divide 100 by 9, the answer is 11.11 ohm. Now question B. Two tungsten bulbs of wattage 100 watt and 60 watt power works on 220 volt potential differences. Okay, if they are connected in the parallel, how much current will flow in the remaining in the main conductor? Okay, so P1 is 100, P2 is 60. Okay, so V is what? 220 volt. Okay, so I is a question mark. Okay, so the formula for finding I is P upon V. Okay, so P means V into I, because V is the denominator here. If it goes other side, it becomes the numerator. So V into I. So I1 is equal to P1 upon V and I2 is equal to P2 upon V. Okay, so for I1 it's a P1 and I2 it's a P2. Okay, so total current I is equal to what? So I1 plus I2. Okay, parallel connection. So P1 upon V plus P2 upon V is equal to, okay, so the denominator is same, so we'll write it once only. So that is 220 and 100 plus 60 is what? 160. So 160 upon 220. Okay, so the answer is 0.727. Okay, the nearly 0.73 ampere, because it's a 7 after 2, so we'll change it to the 3. ओके, म्हणजे 2 डेसिमल वरती याला आपण ओके करून टाकायचं 73 अँपियर. Who will spend more electrical energy, 500 watt TV set in 30 minutes or 600 watt heater in 20 minutes? Okay, so for data is what? P is equal to 500 watt. okay, and T1, okay. So here there are two objects, so we'll write P1 and P2, okay. So P1 is 500 and T1 is 30 minutes, okay. So 30 upon 60 R and 1 upon 2 R, okay, that is 1 upon 2, okay. With 30 and 60 divided केला so answer is 1 upon 2. So P2 is what, 600 watt, and T2 is what, 20 minutes, okay. So 20 upon 60 is equal to 1 upon 3R, okay. So the electrical energy used is equal to PT, okay. So TV set PT P1 T1, okay, is equal to 500 watt, okay, that is 1 upon 2 is 250 watt per hour, okay. And here for the heater it's 1 upon 3, okay, so that is 200 watt per hour, okay. Thus the TV set will spend more electrical energy than the heater. Question D. An electric iron of 1100 watt is operated for 2 hours daily. What will be the electrical consumption expenses for that in the month of April? Okay, the electric company charges rupees 5 per unit, okay. So for data is what, P is equal to what, 1100 watt, T time is equal to what, 2 hours into 30. Well, April month has 30 days every year, okay. So we need to know whether it's a month of January or month of February. If it's January, you'll write here 31, okay. It's February, it will become 28 or 29. It's April, so that's why it's 30. So 30 into 2 is equal to what, 60 hours. So rupees 5 per unit energy. So expenses we need to find out, okay. So N is equal to what, PT upon 1000 watt, okay. So 1100 watt into 60, okay, upon 1000, so that is 66 units, okay. So electrical consumption expenses is equal to 66 units, and into 5 rupees per unit is equal to 330 rupees. Dear friends, if you like this video, please subscribe our channel and press the like button. Thank you very much.